All right, let's graph all the solutions to negative 3x plus 2y equals negative 12. Or equivalently, let's plot all the input-output pairs that make the rule negative 3x plus 2y equals negative 12 true. First things first, let's put this into y equals form or into output equals form. Now that we have our equation in y equals form, it should be a lot easier to cycle through x values and find the corresponding y values. One note, since we've got a fraction in front of this x with a denominator of 2, let me suggest that you use x values that are multiples of 2. Remember, both positive ones and negative ones. So why don't you pause the video, find a whole bunch of ordered pairs using multiples of 2 for your independent variable x, graph those, and hopefully we'll find a pattern and we'll be able to extrapolate. So once again, we found that our ordered pairs created a line, so we connected them. We made sure to add these arrows at the end to imply that this line goes on and on forever and ever. We labeled our graph with its equation. We found our x-intercept and our y-intercept, which is pretty nice because they were part of the ordered pairs we found in the first place. Let's try another example. In this case, we're given our function in function notation. F of x equals 6 minus 2x. Now note, this is no different from graphing y equals 6 minus 2x, but I just want us to be really comfortable with using function notation. Note that in this case, labeling the axes is going to be a little bit different. Our independent axis is still going to be x, but our vertical axis, we're actually going to label f of x. Remember, that notation means the output when x is the input, so it's no different from labeling that axis y. Luckily, we already have our equation in an output equals form, so let's go ahead and find some ordered pairs using positive and negative values for x, graph them, connect them if they make some sort of pattern, find the x-intercept, the y-intercept, and make sure to label that graph as well. Once again, we found that our ordered pairs created a line. When we connected that line, we find our x and y-intercept. Once again, they both happen to be ordered pairs that we had found originally. One note is that if your x or y-intercept isn't very, very obvious from looking at your graph, do not eyeball it, do not make an assumption, then use the equation to find your x or y-intercept. In this case, we were all good to go. All right, here's a trickier example. Now we're asked to graph all the ordered pairs for 4h plus 3k equals 12. Now the first thing we have to do is, since we are not using x and y, if we're ever given an equation or rule using variables other than x and y, we need to explicitly state which variable is the input or the independent variable and which variable is the output or the dependent variable. Let's just let k be the input or independent variable in this case, and h be the output, or the dependent variable in this case. All right, since h is our dependent variable, which we can think of as an output to a rule, then let's go ahead and let's put this equation into h equals form, and then we'll be able to find some ordered pairs more easily. All right. Now we've got our equation in h equals form. One thing I will note is, since k is being multiplied by a fraction having 4 in its denominator, let me suggest using values of k that are multiples of 4. Again, both positive and negative. So please create your table of values, label your axes, graph your ordered pairs. If you notice a pattern, feel free to extrapolate, and then we'll reconvene when you've sketched your graph. All right, now that we have our graph, let's find our intercepts. Of course, we are no longer finding our x and y intercepts, we're finding our k and h-intercepts. The k-intercept, of course, happens when the graph crosses the k-axis, or when h is equal to 0. In this case, our k-intercept will be 4, and the h-intercept will, of course, happen when our graph crosses the h-axis, or when the k value is 0. In this case, the h-intercept is 3. Now, what would happen if we changed how we defined our variables, and h was our independent variable, and k was our dependent variable? How would our graph change? So let's go ahead and try that out and redefine our variables. Now, since k is our dependent variable, we're going to want to put this equation into k equals form. Now that we've got our equation in k equals form, let's go ahead and cycle through values of h to find ordered pairs. Note again, we've got a fraction involved, and since h is being multiplied by a fraction having 3 as its denominator, let's use multiples of 3 for h, both positive and negative. Again, please find ordered pairs, label your axes, graph those ordered pairs. If you see a pattern, feel free to extrapolate, and then we'll reconvene when you've sketched your graph. All right, so now we've got our graph. Again, let's go ahead and find our h and k intercepts. All right, so while this graph may look slightly different from the one we just drew for the exact same equation, actually these graphs capture the exact same relationship. Note that the h-intercept, while it may be on a different axis than it was before, is exactly the same. It's still 3. The k-intercept, while it's on a different axis from before, is still 4. And so it's great to know that even though we've switched which variable is independent and dependent and switched which axes they're on, this line, this graph, captures the exact same solutions to the exact same equation, even though it might look slightly different. Alright guys, that's it for this video. I hope you enjoyed, and I hope you found it helpful.